Hello everyone, in this video we are going to see introduction to the limit state method of design. In previous video we have seen working stress method. Now we will see the limit state method of design. So what limit state, or what in short it is also known as LSM or LSD, limit state method of design or limit state method just. So what exactly is this method? See, it is a condition of a structure beyond which it no longer fulfills the relevant design criteria. What I am saying, it is the ultimate criteria beyond which your structure will not be able to carry the loads. For example, the bending moment in a structure is coming as 50 kMPa, kilonewton meter. Okay, this is the bending moment in a structure, that is 50 kilonewton meter. Not structure, let us consider it as a beam. In a beam, bending moment is 50 kilonewton meter. Okay, so you have to design that building for that beam for this 50 kilonewton meter. So what I will do, I'll design a beam which can resist at least 50 kilonewton meter moment. Let us consider that its capacity is 60 kilonewton meter. The load coming over it, the bending moment load is coming over it is 50, but its capacity is 60. So it can resist, this beam can resist this 50 kilonewton meter moment because its capacity is 60. So it is this value, this 60 kilonewton meter will be its bending moment capacity or bending moment resistance. Okay, so what limit state says, it is the ultimate or final condition. After that your structure will not fulfill the criteria. What does that mean? Means if the load coming over that structure, the bending moment coming over to this beam, if it is 61, if it is 61 kilonewton meter, so what will happen, this beam will not be able to resist this 61 because its capacity is only 60. So up to 60 it can resist any bending moment up to 60, and after that it will not be able to resist this 61. So it is the condition, after that it will not fulfill the design criteria. Then the condition may refer to a degree of loading or other actions on the structure which, while the criteria refers to the structural integrity, fitness for use, and durability and other design requirements. Now what does that mean? Let me explain you this thing in a detailed manner. See, it says it refers to a degree of loading or other actions on the structure. See, while using limit state method of design, basically it is divided into two parts: limit state of strength, which is also known as limit state of collapse. Okay, I'm talking about limit state method of design. It is divided into two sub parts. First one is limit state of strength and second one is limit state of serviceability. Okay, so these are the two types of limit states: limit state of strength and limit state of serviceability. Now what does that mean? In limit state of strength you will have bending moment, which is also known as flexural strength or flexure related to that. Then shear force will also come under the strength. Then torsion, that will also come under the strength. Then fourth one, axial forces, that will also come under the category of strength. But in serviceability you have only three criteria: vibration, then we have cracking, and the deflection. Now I'll explain you these three things first, then we will go for the strength. See, if there is a beam like this, if there is a beam and there is a minor crack over here in this beam, so my question is whether this beam is safe or not, means whether it is giving the proper strength or not. Your answer will be yes. But in limit state method of design, what it says, it should not only fulfill the criteria of strength but also the serviceability. See, this beam was designed to not only resist these various forces but also the various vibrations, cracking and deflection. It should not have any cracks, it should not have any deflection in the structure. So we were expecting that, but what happened, there are certain cracks. So in limit state method of design, we not only check our structure or a member for the strength but also the serviceability criteria. Means for vibration, if a particular structure is having vibrations, then as per the limit state method of design, we will say that it is not fulfilling the criteria of serviceability. It is safe, but from service point of view, it is not suitable. Let me give you another example. For example, there is a lintel beam. You know lintel beam. It is generally provided above the door or a window. Let us consider that this is a door. Okay, this is a door opening. Okay, this is a door like this. So this is the lintel beam. Now, what my concern is, let us imagine, let us assume that this lintel beam got certain degree of deflection. It got deflected like this, a very small amount, maybe 5 mm, 10 mm, 20 mm. Let us consider it is 20 mm deflected. This beam is deflected 20 mm, and because of that, this door is not getting closed. So tell me, is it safe or not? You will think that it is safe, but it is not fulfilling the service criteria. Na? What was the purpose of this lintel beam? To provide the service, to take the load of the masonry which is above it. Now it is not fulfilling the criteria. The door is not getting closed, means its service is not proper, means that lintel beam is not giving you the service which was required. Now that means it is failing in serviceability criteria, not in the strength. But if this beam is subjected to a shear force of say 50 kilonewton, let us imagine, let us assume. Okay, now for 50 kilonewton of shear force, it is designed, but after certain period of time, maybe after 10 years, 20 years, the shear force got increased to 51. How much? To 51. Now this beam will fail. Now it will directly fail. In if it is failing in shear, means its strength, it is not giving the strength. Okay, so it is not only fulfilling. So as per the LSM, what is the concern? It should fulfill the requirement of the strength, and it should also fulfill the requirement of serviceability. Okay, means it should be fit for the use. Now I have given you the example of this lintel beam. It is not fit for the use, na? So it should be fit for the use. It should give you the structural integrity. Structural integrity will be related to the strength. It should have durability and other desired requirements. So if my structure is fulfilling all the requirements, then and then I will be designing this LSM. But not in case of WSM. In WSM, what we were doing, we will consider certain load. A certain load will be considered. You will use certain factor of safety and increase that load, and for that load you will design it. You will not one by one check for these criteria. Each and every criteria is not checked in case of WSM. That's why LSM is considered to be more safe. You got the reason now why LSM is considered more safe or economical, because we check it for each and every criteria. Now a structure designed by LSM is proportioned to sustain all actions likely to occur during its design life. What I said, I explained you the same thing. It is designed to sustain all the actions likely to occur, all the actions, vibrations, cracking, deflection, bending moment, shear force, torsion, axial forces, all the criteria, all the actions. Okay, so and to remain fit for the use with appropriate level of reliability for each limit state. Now for example, the bending moment strength, I will not use the values now, just I am talking in strength. Okay, so let us assume that the bending moment, the strength in bending moment for a particular beam, let us assume it as 20, and in shear force its strength is 15, and the strength is say 22, and in axial force, against axial force, it is 25. Okay, now listen it carefully. Bending moment strength is 20 Newton per mm square, for example. Shear force strength is uh, 15 Newton per mm square, and so on. Okay, torsion and axial forces. Now, if a load is applied to this beam. Suppose this is the beam. So first it will fail in which criteria? The beam will fail in shear force criteria. Why? It will reach 15 Newton per mm square first, then it will go for 20 Newton per mm square, then it will go for 22 Newton per mm square, then it will go for 25 Newton per mm square. So it will fail first in shear force. That's why while designing a structure for limit state, we assume the minimum value, and the minimum value is which? 15 Newton per mm square. The strength value, always take the strength value as minimum. Means if it is failing in 15, then no need to design it for 20. Why you are designing it for 20? If it is failing in 15 Newton per mm square only, you will have to design it for 25. Means for safer design, but strength will be considered as minimum, because if you have to design a structure, the strength will be considered as minimum, because if it is failing in 15, it will not go up to, or it will not reach to 25. So its minimum, its strength is considered as minimum, but you will have to design it for the all the factors, not only for the shear force but also for the axial forces. Clear? So this is what limit state is. Now again, what is limit state? There is another definition. It is the acceptable limit for safety and serviceability requirements of a structure before failure occurs. As I told you, safety and serviceability criteria. Safety means strength. Serviceability, I have told you, there are 3 points: vibration, then we have cracking, I just told you in the previous slide, and third one will be what? The vibration, cracking, and deflection or deformation. You can write deflection or deformation. Clear? So these are the 3 criteria. Now first, as I told you, their limit state has 2 types. Now the first one is limit state of collapse or strength. It is also known as limit state of collapse or limit state of strength. Now what does that mean? First, let me give you its subtypes. As I have told you, now flexure means what? It is its resistance against bending moment, compression, then shear forces and torsion. So all these 4 criteria come under the category of limit state of collapse or strength. Clear? This thing I have explained you in the previous slide. Bending moment, shear forces, axial forces, torsions, all will come under the category of limit state of collapse or limit state of strength. Now, limit state of serviceability. So, limit state of serviceability has 3 criteria. I have told you this: deflection, cracking, and vibration. Clear? So, these are the types of limit states. Okay, we will see them. Limit state of collapse or limit state of strength. So limit state of collapse or limit state of strength, what does that mean? Limit state of collapse deals with strength and stability. I have told you this. It will deal with strength and the stability of structures subjected to the maximum design load out of the possible combination of several types of loads. Now what does that mean? Maximum design load. For example, in shear force, the load, I am talking in terms of load, so it is 50 in case of shear force. For bending moment, it is, or just take the basic criteria. In strength criteria, the load is suppose 50, and in serviceability criteria, it is coming as suppose 60 or 40. Let us assume it as 40, not 60. So what my concern is now, what I will tell. So you will design it for 50 load or 40 load. You can pause the video and think on that. You will have to design it for 50 load, because load should be taken as maximum. Load you will take it as maximum, and strength you will take it as minimum. Clear? So this is your safe design. So what is, so maximum design load we will take, and not only the maximum design, we will have certain possible several combinations. Now what does that mean? We have one IS code that you have to use, IS 1893, and year is 2002. It has 2 parts, part 1 and part 2. So you have to refer this one, IS 1893 2002 part 1. In this, load combinations are given. Now what is load combination? For example, dead load is coming over the structure, live load is also coming over the structure, wind load is also coming over the structure, earthquake load is also coming over the structure, various loads are coming over the structure. So in that case, you will have to use the combination of these loads. So I will give one example. There is one combination which says you have to take the load like this. 1.5 times dead load plus live load. That is first combination. Then we have another combination 1.2 times dead load plus live load plus wind load. So there are various combinations, and out of all the combinations, whichever is the critical combination or the maximum combination, that we have to consider in the design of limit state of strength. Okay, so therefore this limit state ensures that neither any part nor the whole structure should collapse or become unstable under any combination of expected overloads. We will check each and every combination of load, we will check each and every part of the structure, and we will check whether that structure is safe against all the possible combinations of load or not. That is your limit state of design. So what it includes, as I told you, loss of stability will come under the category of limit state of strength. Then loss of equilibrium, if your structure is not in the equilibrium as a whole or in part, that will also come under the category of limit state of collapse or strength. Then failure by excessive deformation and yielding will also come. Failure, you will think that deformation was under the category of serviceability, but it is not only deformation, it is failure by excessive deformation. If it is failing, then it will come under the category of collapse or strength. Even the yielding, that will also come under the category of collapse or strength. Then fracture due to fatigue. Now what is fatigue? Fatigue is the failure due to that failure which occurs due to repetitive applied loads. Repetitive applied loads. For example, there is a structure which has repetitive load, then that type of failure due to which the structure will fail, that will called as fatigue. Okay, so fracture due to fatigue will also come under the category of collapse or strength. That is the, and last one is brittle fracture. Brittle fracture will also come under the category of. In short, all the failures will come under the category of collapse or strength. Now, the second type, limit state of serviceability. Now, what it means? The limit state of serviceability deals with deflection, cracking, and as I told you, vibration also of the structure under service loads, durability under working environments, during their anticipated exposure conditions, during service, stability of structure as a whole, and fire resistance. See, for serviceability, we will check it for various loads such as deflection, cracking under the service loads, and we will check its durability, whether the structure is durable or not, and for that particular exposure condition, it should fulfill the criteria. It should have the fire resistance, it should have the proper stability, it should fulfill all the requirements. So that is your limit state of serviceability. So what it includes? Deformation and deflections which may adversely affect the appearance or effective use of the structure. As I told you, it affects the appearance. If the beam is like this, if it is bending like this, if it is having deformation like this, so it will not be very good in the look or appearance. Its appearance will be what? Its appearance will not be a proper, it will look weird. So that will also come under serviceability. Then vibrations in the structure, as I told you, or any part of the structure causing discomfort of people. See, if there is a slab over here like this and it is vibrating, okay, it is vibrating. So if it is vibrating, it is considered as safe, it is not harming to some people, but it is not comfortable to the people. It is creating or causing the discomfort to the people, and there are certain minor damages it can also create to the structure, or its functioning will be disturbed. So that will come under the category of serviceability. And corrosion and durability. See, corrosion and durability will also come under the category of serviceability. If I'm having a bar, let us consider that this is the reinforcement. Okay, so this reinforcement bar, if it is subjected to corrosion, if it is getting corroded, so it is not failing. So that will come under the category of serviceability. Okay, then repairable damages due to the fatigue. Repairable damages, those damages which can repair. Okay, permanent fatigue or failure or fracture will come under the category of what? Strength. But only the repairable damages, that will come under the serviceability. And last one is fire resistant. Fire resistant will also come under the category of limit state of serviceability. So this was the video on limit state method of design. Thank you.